Hello, welcome in this session of Java on the Raspberry Pi. Welcome on Pi Day. It's noon here in Belgium. I don't know where you all are in the world, but I want to present you something about Java on the Raspberry Pi. So let's switch to the presentation. One moment. Okay, thanks for joining Pi Day, 14th of March. It's a bit different in the US than in Europe, where we have different time date notation, but it's the same. It's Pi Day. It's an important day. It's both Raspberry Pi Day, it's the Pi Day, the number day, and I'm happy that you joined this session. If you want to be involved, want to receive some swag, please subscribe to the Slack channel or go to the website of this event. So you have this Pi Day free trial that you can get from Oracle Cloud. You can also join the Slack channel on this link. Please note this link has been changed. You can also share info about this event on social media, of course. And if you want to challenge your knowledge of Pi, then you can take this Pi quiz, which is also organized by this event. Now, about me and what I want to tell you about. So I'm Frank Delporte. I live in Belgium. I do some blogging about my experiments with Raspberry Pi and Java. And I've been programming since I was 10 years old, a long time ago, unfortunately. And all started with this Commodore 64, one of the very first personal computers which allowed you to program, but also interact with electronic components, because a few years later, I was controlling my Lego trains with this Commodore 64 and a relay board. And that same fun of combining software and hardware is what I find nowadays in the Raspberry Pi, these little boards where you can do a lot of experiments with and have a lot of fun with your programming skills. I am a Java programmer and I work at Eve. We're a Belgian startup company developing this robot. It's a personal robot, so meaning that it will take a lot of boring tasks out of your hands. So one of the first is mowing your grass, but we aim to go a lot further with this and add a lot of functionality to this robot. But next to that, I'm also a Coder Dojo volunteer, and that's an event, a monthly event where we teach kids to program. And not programming is the main goal, but learning to work with the computer, finding the fun in computers, working together, sharing ideas, helping each other. And that's also what the coaches do. So the coaches are volunteers and they bring their own knowledge to these events. And in my case, that's where I learned to work with Arduino and Raspberry Pi, and learned the flexibility of these tools and how cheap it is to realize something. Now I started working with these tools to build something for my son, a drum boot, and it all ended up in this book. And in this book, I describe my journey, my own journey of experimenting with Java on an embedded device and see what you can achieve with that. So I had to learn for myself how I could talk to an Arduino board, how I could control several components. And during this journey, I got back from just Java programming to electronics programming, which is a different world. You need to be aware of bits and bytes. You need to be aware of different communication protocols. But then it becomes fun if you, for instance, here combine this with Spring. So from Spring, you can read the state of a button. And at the end, it came all back to this project that originally started with this controlling LED strips and an Arduino and a relay board, all with both a user interface and a web interface. Now, I combined all this in this book, but that's also how I really got into programming on the Raspberry Pi. Now, let's take a start and see what this Raspberry Pi actually is. So it's a small PC between 9 centimeters. You have the small one of 6 centimeters and a half. You have them in different versions. But actually, in a sense, it's a Linux PC. It's a full PC with a very low price. and a lot of power actually. So you have different editions, and if you look into the most popular one, the B edition, it has different versions depending on the memory that you want. It also has different versions. We are now on the B4, and there you have 1, 2, 4, or 8 gigabits of memory. You have wireless. You have dual screen connectors. So a lot of possibilities to connect peripherals to this little board. But as you can see, you also have very small ones. You have the Zero, and the latest Zero is only €15, $15 on average. And again, it's the same full PC, but in a very small form factor. A special edition is the Compute 4, and the goal of this board is actually to build your own hardware board around it, as it doesn't have any connections, any network or USB is not on there. It's a special connectors. You have to plug it into a board, and there you can add your own connectors. So it's more for hardware designers to build their own computer around it. Now, last year, 2 new Raspberry Pi boards were released. The first one is the Pico. It's a $4 board. Yes, indeed, $4. It's not a Linux PC anymore. This is a microcontroller, so you can compare it with an Arduino. But it's a very low price, again, to get into this hardware world and experiment world. And on the other hand, you have the Zero 2. So that's a new edition of an already existing board. It has a new processor. It has a lot of power. It's a quad-core processor. So it's really a powerful PC. I have been running JavaFX applications, all on that. It runs very fast. You have a 64-bit operating system for it. So it's a full device, a full PC for $15 indeed. What can you build with Raspberry Pi? Of course, any maker project, but there are some really amazing projects ongoing. On the left on this picture, you see this cluster by Chris Benson. So that's 1,024 Raspberry Pis in one rack. So that's really a big server. And it's a project by Oracle, and they built it to go from conference to conference, but then we had some virus in between. So this rack is somewhere in a warehouse waiting for events to go to. And on the right, you have the Blade, which actually is a project by Ivan Kulsov, where he has taken this compute module and he created a blade where you can put that compute module on. And you can put 24 of these in one rack unit. So that's a lot of PCs into one rack unit, powered over Ethernet, so you don't need a different power supply. Everything goes through the switch. And that's also a fun project. There are a lot of these projects ongoing. If you look for compute, Raspberry Pi and baseboards, you will find a lot of interesting and fun stuff by the community. Now, the topic of this talk, why Java on the Raspberry Pi? Because the Raspberry Pi was originally designed for Python. That's both where the Pi name comes from. It's both from the number pi and from the language Python. But to my opinion, it could have as well be Raspberry Java or something like that, because Java runs as well on the Raspberry Pi as any other language. And if you are a Java developer, it could be a very good introduction into a new world with electronics programming. And we have seen since a few years where we have this new release cycle of Java. With every 6 months, we have a new release of Java, that a lot of improvements in the Java language are also beneficial for the embedded platforms, for the small PCs. Both Java and JavaFX have new versions with small improvements that help you both as a programmer to be more productive and build more beautiful code, but also run this code more performantly on these small devices. Also, GraalVM, the native compiler for Java, also has a lot of stuff ongoing there in the direction of embedded. If you don't believe me that Java on Raspberry Pi is a good choice, you can believe Oracle. I wrote an article for the Oracle Java magazine about the Getting Started project, how you can start with a minimal example of building a JavaFX application, and you can find it back on the Oracle Java magazine. Maybe another reason that not a lot of people are aware of is that Java is eco-friendly. And if you're wondering how can a program language be eco-friendly, it's all about energy. How much energy do you need to run a task, to do something with your program? And there is a study which compares all these languages for similar functionality, where C is the benchmark. So the C program language has a value of 1. Then you see that Java for a similar task has twice the energy needs to do something compared to C, but where Python actually needs more than 70 times the same energy to do the same thing. So I was not aware of this, but actually Java, if you also look into embedded devices and what they can do with a minimal power supply, also there Java can have some benefits. Now, the Raspberry Pi, as I said, it's a Linux PC, so you need an operating system for that. And until I think more than a year ago, it was called Raspbian OS. It has now been fully rebranded to Raspberry Pi OS. So it's an operating system in different flavors. Only recently we have both a 32-bit and a 64-bit version. So 64-bit means that you can take use the full capacity of the 8 gigabytes of memory. You have more performant application. The startup is faster. So actually this makes a big difference. And one of these Raspberry Pi OS versions that you can install with the Raspberry Pi Imager tool on an SD card even has OpenJDK 11 installed. So if you go for the full Raspberry Pi operating system, you get OpenJDK 11 and a lot of additional tools. You see here in the start menu that there are a lot of programming tools there available. Visual Studio Code by default is not part of it, but you can just install it. It has been released specifically again for the Raspberry Pi. So that means that the Visual Studio Code, which has plugins, extensions for Java, runs fully on Raspberry Pi. That means that you can program your Java code, run it, build it, test it all directly on the Raspberry Pi. Most developers will do the development on their full PC, on a Mac, on a Windows, because yes, of course, these are more powerful. If you compare the price between a full Mac and a Raspberry Pi, there should be some difference. But still, the Raspberry Pi, as it's aiming to be a PC that can be used by anyone who wants to start programming or get into computing, he can use this board to do that. So as I said, if you have this full Raspberry Pi operating system and you just burn it on an SD card, start your Raspberry Pi for the first time, you go to the terminal and you say Java -version, you will see that Java 11 is there for you. So you can immediately start developing Java programs. Now, I did a quick test with a new board that I installed. So I had the latest Raspberry Pi operating system, the 64-bit version, and I did this little test with SDKman. SDKman is a tool just to help you to switch between Java versions. If you're doing experiments and you want to go from Java 11 to 17 or an older one or a different distributor, SDKman will help you to install these different versions. Now, I just installed it here on this new system. And then you can do an SDK list Java. And I should have made the font a bit bigger, but you will see that you have a lot of Java versions, JDKs that you can install on your Raspberry Pi. But of course, we also have the Oracle one. So Oracle 17, installing on a Raspberry Pi is just a matter of installing SDKman, which is one line of code. And then you do SDK install Java with this version of Oracle, so 17.02 Oracle. And then we have to wait a little bit, of course. So it will get this Java version from internet, download it, package it again for your board, and then it will become available. Now, to prove that this is a 64-bit version, so here you can see it. So in the terminal, indeed, it's a 64-bit operating system. We have 4 CPUs. So actually, we have 4 CPUs in this small PC of only $20 or $30. And we can make full use of these 4 cores in our applications. So let's see where we are with the installation here. So it's still downloading and packaging. Let's move on a bit, the video. And as soon as the installation is finished, you can do a Java minus version, and you will see that we have indeed this version 17.02 of Oracle. So we have, because we do Java minus version, we're already running Java itself to check the version. So that means that we have a running Java on the Raspberry Pi, a version 17 of the JDK. What I also love about Java is JavaFX. So it's this additional platform, additional libraries you have to build user interfaces. And again, also these run on the Raspberry Pi. Java is a language write once, run everywhere. This is really true also for the Raspberry Pi. So that means that JavaFX, it is no longer part of the JDK itself, but you can again download it, run it, install it on your Raspberry Pi. So this is managed now. This project is now managed by Oracle and Gluon. They keep the same release cycle of every 6 months. There is a new JavaFX version. The numbering is in sync with the Java releases, and it allows you to build really nice user interfaces. There are a lot of components available by default, but you also have this amazing list of, this is a tutorial. So Jakub Jenkov has a great tutorial on how to get started with JavaFX. And then for each of the components, he has an example. But there are a lot of other components, like FX Ribbon is just one component to build a Word-like menu on top of your application. What I always use in all the applications that I use, that I built as proof of concept of it, or example applications, is the TilesFX library by Gerrit Grunwald. And you immediately see that this kind of application really begs for inputs like temperature sensors and buttons and humidity sensors, exactly the things we can do with the Raspberry Pi. Now what can JavaFX also do is direct rendering. It's kiosk mode, you can say. So that means that only your application is running on the screen, no desktop-like application. So that means that you can really build a kiosk thing where users can interact with hardware, or you can collect information from the user. And it also allows you to build games. So this is again from Gerrit Grunwald, just an example application running on a Raspberry Pi, and you see that the frame rate is up to 60 frames per second. So you have really smooth animations and gameplay on the Raspberry Pi. So you can build your own handheld game console, for instance. There are also, again, a lot of projects in the maker world where a Raspberry Pi is used as a central heart, the computer running in any kind of device. Now, next to all this Java magic running on the Raspberry Pi, what is the next big thing? It's the header. So it's 40 pins, 40 connections you have on this board, with a lot of different input-output values, where you can connect electronic components. So here is where you extend your PC with other hardware components. You also have different communication protocols with these devices. You have just digital state, so high or low. So you can have a LED which is on or off. You can have a button which is pressed or not pressed. But there's also I2C, SPI, UART, PWM. So these are all different types of how you can control electronic components. And depending on the component you use, you can one or more of these to control it. So whether it's a LED segment display or a LED matrix or reading from an Arduino serial port, all this becomes possible if you combine both a programming language and hardware components. If you want to get into this experimental things, go to eBay, go to your local electronics shop and buy yourself an electronics starter kit. There are a lot. They start at 20, 30 euros, depending on the amount of components that you have in there. If you want to start with things which are most common to experiment, you will need a distance sensor, you will need an LCD display, a lot of LEDs and resistors, some push buttons, potentiometers. Just go look for this kind of stuff and you will find a lot of them and can really start building. Now, if you want to control electronic components with Java, we have the Pi4J project. Now, the Pi4J project wants to make it as easy as possible for a Java developer to get into this electronics programming. So it's a library which aims to be user-friendly and still offer you a lot of possibilities. So where does this Pi4J stand? So it's on one hand side, it's a library that you integrate in your project. And this library itself has a native library, native code, which calls and listens to these pins. So this code can interact with these electronic interfaces while making sure that you as a Java developer don't need to be fully aware of all the magic which is happening there in this electronics layer. Now, the Pi4J project is not new. It already started in 2012 by Robert Savage. Last year, we had 2 releases of the first version 1, so version 1.3. It's the latest one which supports Java 8. We needed a new version at that time because Raspberry Pi announced had released a new 4 board with different versions. So the Raspberry Pi 4, 400 and CM4, the compute module, all share the same architecture. So to be compatible with these version 1.3 was released. And then a bit later, we released 1.4, which jumps to Java 11. Now, this library supports a lot of electronic components, which made it really hard to maintain and to be sure that if we released a new version, that it was completely tested and working okay. So there were some evolutions later. Now, this version 1 uses wiring Pi as the native library to communicate with these GPIOs. There was some confusion about numberings, which pin is which number, and the library itself was deprecated. So we had to move on to a new version. But on the other hand, we needed to be sure that we could still support a lot of projects, because you see on GitHub that there are actually a lot of uses of this library. Just to show you a few, this is a street theater robot. So you see that internally there's a lot of wiring and components, but at the heart, it's actually a Raspberry Pi controlling both this LED matrix on top of the robot, starting sounds and interacting with people. There are also professional use cases of the Raspberry Pi and Java and interaction with electronic components is, for instance, this medical cabinet. So it shows you with the green light. So these are all drawers with medicines in there. And the green light shows to people in a hospital which medicine they have to take out. And if they put their hand in the wrong place, they have a red light. So it really helps them to pick medicines and be sure that they take the right medicine. So again, this is with Raspberry Pi control integrated. Now, this second version of Pi4J was also released last August, but it was already started 2 years in advance. So the native library was replaced by PyGPIO, so to solve this deprecated library. We also use the BCM numbering of the pins, which makes it a lot easier to understand for new users. And in GitHub, you will find different projects. You have the Pi4J core project, you have a lot of example projects. So we really try to keep this all separated and well organized so that new users can really find back information and even contribute back to the project. I'm not going to go into detail of this image, but it's just to show you that we've taken really a structured approach in this project to make it easy to extend and maintain testable all these things, and really use the latest Java modules approach to make this library completely ready for the future. Together with the new release of Pi4J, we also released a new website. And this website really aims to be the starting point of Java on Raspberry Pi. So it's not only about controlling these electronic components, it's also about how do I install Java on the Raspberry Pi. There are a few Raspberry Pi boards with an older processor, and the latest Java doesn't run on it. But again, there are solutions for that. So they are all documented on this website. So for instance, if you're using a Raspberry Pi Zero of the first generation that has an ARM V6 processor, you cannot use the latest Java, but on this website, you will find which version you can use and install on it and still use Java and JavaFX on this really old type of Raspberry Pi boards. Now, as I said, we wanted to make it as easy as possible to get started. So there are a lot of examples of Pi4J applications. The minimal example application is the Hello World application in electronics, meaning blinking a LED. That's the first starting point here. So how does it look like? If you look into the code, you will find more documentation than code, again, to explain how this Pi4J library is used. And everything in the Pi4J starts with the context. The context is which board am I running on? How do I interact with the GPIOs? So this is all handled by the context. You have a new auto context, which will just load the Java modules which are available and then try to help you as much as possible. Now, for instance, a button. So if you want to read the state of a button, is a button pressed or not, is a digital input. So we want to know from an input, is there something pushed or not? And we have some configuration values, and then we can attach a listener. So you see, this is really Java code. This is the code that you as a Java developer know and understand. So if the state of a button changes to an enum value, you can check it, was it pressed or was it not pressed? And the same can be done with a LED. Again, a LED is an output. You will put a pin high or low for the LED to be on or off. And here we have something with the thread. So this example application, it just blinks a LED, and depending on the number of times that you've pressed the button, the blinking will go faster or slower. So you see that we use the press counter from the button to make the sleep a bit shorter. Now, if you package this application, it's a Maven example, but the example itself in GitHub also has a Gradle build script. So if you build it with Maven, you will end up with some Java modules. So as I said, we've taken the approach of the latest Java architecture with the modules. You will see that you will get the libraries of Pi4J itself, and then 2 logging libraries. That's the minimal required thing here. And a run script. So you can immediately run your application. Now, let's see how this looks like in real life. So I have this small setup. Don't care about the fancy ventilator here. It's only part of my test setup. So what I have here is a small breadboard with a LED and a button, and then some wires going back to the Raspberry Pi. Now let's run this and see what happens. You see in the background that the application has started in the terminal, and with each press of a button, the LED will blink a little bit faster. This is fancy, isn't it? Now, this blinking LED is really the hello world of Java electronics programming, and that's really, for me, that was really an aha-Erlebnis, they call it in German. It's really, this is the first time I had Java code doing something in the physical world. Now let's take this a little bit a step further. And you have these amazing arcade kits that you can buy. Now they also come from, I think, 20 or 30 euros. And actually this joystick is just 4 buttons. If you go up, you press a button. If you go left or down, right, you just press buttons. So that's exactly what we have done before with this one button to blink the LED. So we can detect when the joystick was handled. And you also have these other big push buttons. So we can again use this the same way and have a listener attached to it and do something with it. Now, if you combine this with JavaFX, let me go up again. The link is here. So again, this is an article which was described for the Oracle Java magazine. So if you look into this website and look for FXGL or Pi4J, you will end up on this article. And this article fully describes what is available. Now, this is a little game. So it uses FXGL, which is a library, JavaFX library by Almas, to create Java games. So this game is a really simple game. You have the Java Duke flying around and he's shooting cloud servers. That's a bit the idea. And you need to avoid that your player entity gets hit by a server or that you end up in the big red hole in the middle. Nothing too special. It's just a very simple game, but it's to illustrate what you can do with the combination of Java, JavaFX, Pi4J, FXGL, Raspberry Pi, all this here to illustrate how powerful this all is. I said that you can buy these electronic kits to experiment with electronics and the Raspberry Pi. Another possibility you have is the CrowPi. It's a little PC. It's a little suitcase where you have a Raspberry Pi. I actually have one here, so let me show you. So you have this little case and you have a small LCD display in the middle, but you have a lot of buttons. You have an 8x8 LED matrix. You have a clock display, you have an LCD display, there is a distance sensor here in the bottom, there is a distance sensor, there is a motion detector sensor. So all these are here within this one little suitcase. So that means that you can very easily try your experiments because you don't need to care about the wiring and the electronic components. They are already there, they are pre-wired. So if it doesn't work, it's probably because there's something wrong in your code. Now, to make this a bit easier to get started, thanks to the FHNW University of Switzerland, they contributed a flavor of the Raspberry Pi operating system to the Pi4J project, which has some small improvements for Java development. So the latest Java, the latest JavaFX, are all installed on there. There are some example applications there, and you can just get this from pi4j.com/download. And here you will find the latest version of this operating system. Now, some of the improvements are very small. So for instance, the background image of the screen actually shows your IP number. So this is very easy if you want to connect to your Raspberry Pi from another computer. Now, if you want to get these examples, you can get them from GitHub. Now, this project has been done by students of this university, and it has a use case for every possible sensor or device that you have in this CrowPi suitcase. So if you download this code and you run it, you will have a lot of examples that you can experiment and extend further if you want to try these. Now, I'm going to show you one thing, or maybe more. Let's see. We have this LCD example application. So if you look into this project, again, it's a Java-based code. It all extends from an interface, an application interface, and for each device, there is a demo application. So for instance, for the LCD display, you have this LCD display app. It uses a component, which is the LCD display itself. Because this display is controlled to I2C, there is a chip in between to control this display. So all these are different classes, 4 classes in this example project, which are used to control this display. Now, by using this flow, writing to this LCD display becomes very easy. If you want to have text on the first line or on the second line, it's just LCD write line, hello on the first line and world on the second line. You can also move your cursor or blink the cursor or have other interactions with it. Now, one of the fun things is that you can draw on this image. Instead of just sending text, you can also draw. So all these elements of this LCD display have an array that you can send to it. And for instance, you can draw this house. So if you look into the window of this house, it's actually this byte array is used there to send this image to the display. Now let's see if we can illustrate something. So what you see now is my this CrowPi. So you have the output of the screen. I already downloaded this code, and you see that everything is ready to launch it. So if I now launch this code, you see that we have 21 applications, demo applications available. Now, one of them is the buzzer app. This doesn't really do anything on the device itself that you can see, but I hope you can hear it. So this actually, let's make it stop. So this actually sends out a PWM channel. So that's, again, a type of electronic communication where you can, for instance, control the intensity of a LED, but you can also control the intensity of a buzzer. So this is used here to play a little sound. Let's start something that you can see, and maybe we can use this LCD example application here. So the same thing with the little house that I showed you. So let's see how this works. So you see here on the screen that we have our little house. It's moving. And it sends some text. So all this is part of these demo applications and makes it very easy to get started and experiment and see how others have done some things and how you can reuse that code to build your own application. Okay, so let's stop it. Let's start another one. Let's see if I can have you, can show you both. Yeah, let's use another one, and it's this LED matrix. So the LED matrix is actually this little component here, which has 8 by 8 LEDs. So if I start this one, you see that you have both. I have not really output on the screen, so let's go here. And you see that you have some text passing. It's a bit difficult to see with the lighting here, but that's how this device is controlled. Okay. So far the CrowPi, but what we also did based on this same CrowPi is build a demo application for HiveMQ. HiveMQ is actually an MQTT broker, so it's a program to exchange messages between different devices. And what you see here is a JavaFX dashboard running on a Raspberry Pi, showing a dashboard with data received from an MQTT broker. And a second application is running on this same CrowPi that you've seen before, and it's sending data. So as soon as you touch this suitcase or you have your hand above the distance sensor, it sends a changed data package to this MQTT broker, and the other application that you see with this dashboard application receives all that information and then updates its styles. So it's all independent of each other, meaning that even this little small inexpensive computer can be hooked to the internet, can send data, can send sensor values, can also show sensor values from other devices like an Arduino or an ESP32. So all devices which can exchange data being in your own network or on different locations can all be visualized. And that's the kind of use cases where you, for instance, could use a Raspberry Pi and kiosk mode to show a dashboard where you don't want really user interaction, but just show what's happening somewhere in the world with just a small packages of data. Let's see the time. Yeah, I think we're Good. So what did I want to show you today is that Java and JavaFX on the Raspberry Pi are really possible. Yes, they run, they are really performant. You can build really beautiful user interfaces with Raspberry Pi. You can really build powerful server-like applications where you collect data, send data, handle data, and you can combine it with electronics thanks to the Pi4J library. If you are interested in this topic, take a look at the pi4j.com website. Take a look at the examples, use it, do some experiments. There are a lot of questions ongoing because with this new library, some people want to get involved, want to try it out for the first time. We get contributions back with examples, with additions for the documentation website. Everything is welcome because, yeah, this is a true open source project. There's no money behind it. It's all volunteers. People who are interested in this topic want to work with it and want to share information about it. If you want to know more, you can follow me on Twitter. I have my blog on my publications page on my blog. You will find a lot of other websites where I share information. I have some Prusa prints, 3D files online. I have some Fuji articles. I have some Medium articles. So you will find the links all there. And I can only invite you to build an experiment and have fun. I should have added get frustrated also between there because stepping into a new world like electronics, if you are just like me, a software developer and you've never done hardware before, it can become frustrating because it has each component has a plus and a minus side and you can turn them around and nothing happens, but actually your code is okay. It's all part of the learning trajectory that you have to take here. Yeah, and one more thing that I want to share. Behind me, let me show you my screen behind me. So actually I'm looking at the Raspberry Pi camera and I have another one here. So actually this whole presentation is also filmed with Raspberry Pi because it's not only a PC and an electronics kit, it's also a camera. There's camera stuff on there. You can use it for machine learning, for visual recognition of things. So actually, the Raspberry Pi is worth looking at into it for more than just programming and experimenting in all kinds of topics. Let me share you again the slides of this event. So if you want swag, you can go to the Pi Days website. You can get this free trial from the Oracle clouds, and you can share everything that you learn here or join our Slack channel. Now, let me check. There's something more I want to share with you. The Pi quiz, of course. And if you have any questions, you can always ask them to me via Twitter or here on the Slack. Indeed, I will share some links also. Let me share this in the chat. So for the Slack invite, you can now find it in the chat of Zoom. Anyhow, thanks for joining this session. I hope you enjoy Pi Day and all the other sessions by all the other amazing speakers. And I hope you learned a bit of my talk and enjoy the rest of the day.